And leading those off, it is my distinct pleasure to introduce you to Debbie Langenfeld, who many of you know. She has been a steward for 6 years. She's been involved in pretty much all of our citizen science projects, and she's held a number of leadership positions within the program. As John said, she was the citizen science chair for 3 years. And once she moved off as citizen science chair, she immediately jumped into a couple of other leadership roles. One of those is as our BAT project lead, and that is the project that she's going to tell us about now.
So thank you, Tiffany. That was a nice introduction. I am, as Tiffany said, the citizen science lead for this project, working with Helen Tiffany and our research partner, Dr. Marianne Moore from ASU. Marianne couldn't join us today, but she's been instrumental in providing the knowledge and support needed to achieve our joint goals. So why are we studying bats? One of the most misunderstood animals, bats are crucial to our planet. They provide essential pest control, pollinate our plants, and disperse seeds for new plants and trees to grow. Bats can also be important environmental indicators for climate change and urbanization because of their sensitivity to roost temperatures and their need for large insect populations. And unfortunately, like a lot of other species, many bat species are in serious decline. Global threats include loss of habitat, noise, light, and intentional disturbance by humans. If that isn't enough, there is a fungal infection known as white nose syndrome that affects hibernating bats and has killed millions of them in the eastern U.S. And it's moving west and has been detected in California, Texas, and Washington. And very sadly, it was just announced last week as being detected in New Mexico as well. So where is our research area? Well, there are several closed mines in the preserve, and we're monitoring one that is known to support bat population. It offers the water, consistent temperature, and humidity that bats prefer. The surrounding riparian area offers an abundance of insects for foraging and a commuting corridor. We've known bats were there since 1981, when the BLM and Game and Fish periodically conducted emergence counts and captures at the site. And in 1992, the mine was determined to be used as a maternity colony for Townsend big-eared bats. That was an important find because the Townsends are considered a sensitive species in Arizona. In 2000, the Nature Conservancy declared the area an important conservation area for 3 species of bats, the lesser longnose, California leafnose, and K. myotis. And it's in a good location to contribute to research being done across the country and Arizona to detect the presence of white nose syndrome. To achieve our research goal of assessing the bat species occurrence and relative abundance across seasons and years, we have to combine methods. So we do emergence counts, physical captures, and acoustic recordings. Reviewing the chart, we can determine relatively how many bats are there and when with emergence counts and acoustics, but not with captures. We can determine what species are there with acoustics and captures, but not with emergence counts. Taken together, we have a comprehensive approach that includes both the mine and surrounding area. So let's now delve into each of these methods a little further. We've been doing spot checks in the area since 2016, but in 2019, we began more rigorous emergence counts to determine when bats use the mine and seasonal changes in population size. Emergence counts are done once a month, as close to the new moon or darkest night of the month as possible. We position 2 IR infrared lights and 2 video cameras in front of the mine and record for 2.5 hours. We then visually count the number of bats coming out of the mine and going into the mine. With 2 years of data, that means that fellow citizen scientist John Griffin and I have reviewed over 230 hours of videos. The following video will give you a good idea of what we're looking at. Watch closely, and you'll see a bat entering the mine. We count that as 1 in. Keep watching, and you'll see a bat exiting the mine. We count that as one out. Now, you might say that that was the same bat and we're double counting, but do you really know for sure that that was the same bat? That's why we're calling it relative abundance instead of absolute abundance, because we could be observing the same bat in and out, or it could be different bats. Moving on to captures, they answer the question of which species are there and possibly why they are there. We've done a few occasional captures of bats entering and leaving the mine using the harp trap in the picture on the right. It's rightly named because it looks like a harp with 3 rows of fishing line and a trap. The bats aren't harmed. They're caught in the lines as they fly either into or out of the mine and slide into the trap where we pick them up. And then, as you can see from Marianne Moore, she's identifying the bat species, checking its general health, measuring, weighing, and determining the sex. She's also looking to see if the bat is pregnant and lactating. A swab is taken to test for the occurrence of white nose syndrome. Acoustic monitoring allows us to determine what species occur within the surrounding area and assess how their distribution might change over time. We do this monitoring on the same day and for the same amount of time as the emergence count. Ultrasonic calls of bats in the area are collected by a specially designed recording device placed high in the air. Some of the equipment that John actually mentioned, John mentioned we were getting some new equipment. That's part of it. The files that are created are then analyzed by software that is also specifically designed to evaluate the wave pattern and auto-ID species. Not all species can be auto-ID'd though. Those that can't must be manually analyzed, and that's because there could be noise interference, multiple overlapping bat calls, or bats without calls, bats whose calls sound very much alike. I thought it would be interesting for you to see the output from the process. Here are 2 bat call spectrograms. Bats have different calls depending on what they're doing. The bottom is a low-frequency commuting call. This bat is cruising around the neighborhood checking out the scenery. The top is a higher frequency, very rapid staccato call. The bat is acquiring and capturing an insect, much like a fighter pilot would be doing to zero in on a target. This is a spectrogram of a canyon bat produced from a recent field day. The species was auto-ID'd using a software program called Sonobat, which is also new software we purchased. You can see how crisp this recording is and easily recognized by the software. You might be familiar with this bat because it's the first one to come out at night right after sunset. It's probably obvious, but this is a spectrogram that could not be auto-ID'd and will have to be evaluated manually. Well, I've shown you our 3 research techniques, but what does it all mean? Although we're just starting to get to understand the data, the next few slides review some of our preliminary results. To answer our first question, which species are there, we can take a look at the number of acoustic calls recorded by species. Each pie chart represents a year of data. This is not all the species that were identified. It's the calculated percentage of the bats with recorded calls greater than 100. The canyon bat is overwhelmingly the most recorded species. This is not surprising as they are second to the most abundant in the Phoenix area behind the Mexican or Brazilian free-tailed bat. We can further answer the question which species are there by looking at the capture data. We've captured 4 species, including predominantly the Townsend big-eared, rightfully named for those big ears, I'd say, the canyon, the California myotis, and the cave myotis. And since we're talking about captures, we might as well report our very important find in June 2019. As you can see from the fireworks, we were elated to confirm that the mine is still nearly after 30 years, being used as a maternity roost for Townsend big-eared bat. Not only are they important species, but they're a species that is highly susceptible to human disturbance and specific in their roosting requirements. And to answer the question relatively, how many are there and when are they there, we can look at emergence and acoustic data over time. The graph on the left is the average out count for the mine over 2 years. It shows that the mine is used heavily in the late spring, early summer months. Based on the capture and historical data, we can assume that the bats are mostly Townsend big-eared bats, and that's when they're using the mine as an maternity roost. The graph on the right represents the total calls for the 4 capture species over 2 years. It also shows heavier use in the late spring, early summer months. Both graphs show that the mine and surrounding area are used year-round, which has important implications for when certain activities can occur in that area. In the future, we will have enough data to uncover patterns and trends such as the effects of weather. So where do we go from here? Of course, we'll continue with the monthly monitoring at the mine, but we want to expand our research to understand how bats are using other areas of the preserve. So next week, we're deploying 5 more acoustic monitoring devices. In order to get the broadest sample, they'll be deployed across different biotic communities at different elevations and terrain. We're excited to be working with the North America Bat Monitoring Program on this effort, and we'll be contributing our data to help them reach their goal of creating a continent-wide bat monitoring program to promote effective conservation, decision-making, and long-term viability of bat populations. So that's the end of my presentation. Are there any questions?
All right, thanks so much, Debbie. So far, people are taking it really easy on you, and there are no questions in the chat. I do encourage folks, get some questions in there. Oh, goodness. So Scott just popped something in there. It's not a question directed toward Debbie, but he did want to say they wanted to thank the Field Institute for their efforts in all of the long-term monitoring projects. He can't overstate how valuable it is to be able to follow trends relative to the context of the urban interface, the gooseneck connector, the surrounding development, and climate change. Long-term data sets of such optimal study areas are extremely rare. And as Helen mentioned, this really does have the potential for global implications on conservation focus areas, such as wildlife connectivity.
I have a question for Debbie.
Yes.
This is Patty. I just was wondering, is there any link to disease from the bats that we have in the Sonoran Desert? I know that there was a big deal in Asia about the bats, and it seemed like they got a really bad rap. And I was just wondering if that's something that is there some truth to that, and or do we have anything like that with our bats in the desert?
You know, hi Patty, first of all. I don't know the answer to that, and I wish Marianne Moore was here because she was one of the very first people who went in and discovered the white nose syndrome back east, and her research is on white nose syndrome, but I don't, and she also teaches, does a lot of teaching about what happened with COVID. Well, I don't know the answer to that. Tiffany, do you know?
Unfortunately, I missed a little bit of the question. I apologize, Patty. I was checking out the chat. But you're wondering, is it related to the novel coronavirus and the disease issues surrounding that?
Yeah, that, or I'm trying to think about 5 years ago, there was something in Asia about the disease with the bats, or maybe it wasn't even that long ago. Maybe it was 3 or 4 years ago, before the coronavirus. But I was just wondering, and what is the white nose syndrome caused from?
So I'll start with the second one. The white nose syndrome is caused by a fungus. Don't ask me to pronounce what fungus it is. It's got a very, very long name, but it's caused by a fungus. Debbie has it up here, yeah, whatever, just reference. And basically affects hibernating bats, and it destroys their tissues. And so you can see it on the bats in this picture.
Yeah.
And it also, it affects hibernating bats. It makes them kind of restless as they're hibernating. And so what that does is it actually uses a lot of the important energy reserves. And so they ended up running out of energy before they're able to emerge from hibernation. And so they can die during hibernation, or when they emerge, just be weakened to the point that they then cannot survive. With reference to your first question, there's a lot of cases of human-wildlife conflict that involve disease. Some of them are due to things that humans are doing and intentionally interacting with bats in ways that they shouldn't, or with other wildlife. Others are just things that we cannot necessarily control. And so there's a lot of information out there from disease centers and from biologists who are studying these diseases about ways that we can minimize that and ways that we can move forward from them. I am not one of those people who knows a lot about that, but I'd be happy to help you get more information about it.
Oh, that's okay. I just was curious about that.
All
Thank
right.
you.
Yes, we've got just a couple of minutes. Debbie, you did get some questions. So one of them is, why are bats counted from half an hour before sunset to 2 hours after sunset?
For our research, actually, at the mine, we count them for 2.5 hours. So we count them half an hour before and then for 2 hours after. But they're counted before because some bats actually start coming out, like the counting bat, for example, right at or right after sunset. So some bats actually do come out before sunset, and they're returning. So they're going out to forage, and they are then returning in the early dawn hours of the morning. So that's why we count them until half an hour after sunset, or we will be when we put out the 5 monitors.
Debbie?
Yes.
Ernie Finkel, how are you?
Hi, I'm good. How are you?
Great. Just a quick question on the bat counts.
Yes.
In the preserve, we use laser count to basically cover people coming in. And actually, we must have some sort of an algorithm of those who do not return to the trailhead and go on to some other part where they will leave. Do you have an algorithm on the bat counts as they come in? Because there's no way to really ascertain which bat is which when they go in and when they go out. So is there any way that any formula used to sort of measure that count?
There isn't, if I understand your question right, there isn't. It is just a simple count of the bats that enter, that break the line of the gate and then exit. But there isn't an algorithm that helps us determine, if I understand your question, what percentage of those we've double counted or something. Is that your question?
That's my point. Yeah,
yeah.
That was my question.
No, there is not.
I have one more question. I'm sorry. I was just wondering, does the light, our city lights, are they affecting the bats, or have you guys noticed that?
We don't have the data to support that. As I said, we do the research on as close to the darkest night as possible. But we do not have the data yet to support that. And then Tiffany, I don't know if you're aware of any data that supports that.
There is information out there about light effects on bats, and for many bat species, they react negatively to it, and their numbers decrease in that area. Other bat species actually benefit from it. So it's really on a species by species case.
Well, I know that, the bats in my neighborhood, for example, are drawn toward the light because that's where the insects are, for example. So I guess it probably does depend a little bit on the bat.
So we have more questions and comments rolling in. We actually need to move along, but hopefully we'll have a little bit of time at the end of this section before the break so that we can get the rest of the questions answered. So thanks all of you for getting those questions in.
Well, thank you all. I enjoyed presenting my bat research to you.